All right, let's get right into it. The mission sounds simple. Build one micro-EV for the whole world. But here's the catch, the world can't even agree on what a car is. So, as chief systems engineer, my job is to slice through this jungle of conflicting rules and hand my team a single, unified blueprint for success. Here's exactly how we're going to do it. This right here is the absolute core of the problem. You have to understand we're not just talking about changing a few badges for different countries. We are looking at fundamentally different ideas of what makes a vehicle safe and what it's allowed to do on the road. In Europe, in China, and Japan, and the US. It's one car, but we have to design it for four completely different realities. And this leads to what I call the micro-EV trilemma. Picture this. It's a constant tug of war. Let's say we add a high-strength steel cage to pass a crash test in China. Well, that adds weight. And bam, we've just made the car illegal in Europe. Okay, so we strip out weight to meet the European rules, but now we can't pass the safety test. And every single one of those decisions sends a shockwave right to the price tag. It is a brutal balancing act where every choice is a major compromise. So what's the solution? Well, trying to build 4 different cars from the ground up would be an engineering nightmare and a financial disaster. No, the answer is to build one single brilliant platform. We're going to engineer it to meet the absolute toughest regulations on the planet. Then, we can strategically scale it down, remove certain features or software limit the performance for markets that don't need it. We're going to design for the peak, then adopt for the valleys. So, let's dive into this regulatory maze. Because you have to remember, these rules aren't just words on a page. They are the hard, physical forces that are going to dictate the shape, the weight, and really the very soul of our vehicle.
I mean, just look at this chart. The differences are staggering. Europe is completely obsessed with weight. You see that? 425 kilograms, and that's without the battery. That immediately pushes us into using things like space frames and lightweight plastics. But then you jump over to China, and they demand that our tiny little car has to survive the exact same crash test as a full-size passenger car. Japan, meanwhile, is all about the physical size. It has to fit in a tiny box. And then there's the US, which basically treats it like a golf cart, totally exempt from crash testing. These aren't just suggestions, These are the solid walls of the maze we have to build our way through.
Okay, so this crazy quilt of regulations forces us to make 3 absolutely critical make-or-break engineering decisions right now, at the very beginning. If we get even one of these wrong, the whole project is basically dead before a single part is even ordered. First decision, and it's the big one, the heart of the vehicle. It's voltage. Now, a 48-volt system, it's cheap, it's simple, it's perfect for a really basic city runabout like the Citroën Ami. But, and this is a huge but, it hits a hard performance wall. See, to get more power at low voltage, you have to pump a ton of electrical current. That means thick, heavy, expensive copper cables that just waste energy as heat. A higher voltage platform is the only way we can efficiently get the kind of performance we need for Europe's faster L7E class and for highway driving in China. It's really the only choice that doesn't box us into a corner. So what's the magic number? Well, after all the analysis, all the benchmarking of the most successful vehicles already out there, everything points directly to a nominal voltage of right around 96 volts. And this right here is why. It is the perfect technical and commercial sweet spot, really pioneered by the Wuling Mini EV. It gives you enough punch to be highway capable, but it cleverly keeps you just under the voltage where you'd have to start using really expensive components, like the high-power switches called IGBTs that you find in a full-size EV. This is the secret sauce. This is how you balance real-world performance with a price tag for the mass market. Okay, decision number 2, battery safety. And this one is being driven by a new global benchmark coming out of China. Just read this quote. The old standard was you get 5 minutes of warning before a fire. The new one, 2 hours with no fire, no explosion. This one sentence changes absolutely everything about battery design. It forces us to use inherently safer LFP, that's lithium iron phosphate cells, and to use advanced insulation materials like aerogel. This isn't a nice to have. This is our ticket into the world's biggest EV market, period. And finally, our body structure. It can't be one thing or the other. It absolutely must be a hybrid. We're going to engineer a core safety cage out of high-strength steel. That's what lets us pass those really tough Chinese crash tests. But then we're going to wrap that cage in lightweight, non-structural thermoplastic panels. That's how we hit Europe's incredibly strict weight limit. It's an approach that solves the 2 most demanding and, frankly, conflicting requirements at the exact same time. So, now that we've navigated those huge engineering decisions, what does the final blueprint for success actually look like? Let's take a look at how our strategy stacks up against the competition and then lay out the final execution plan. When you put our strategy next to the competition, the path forward becomes crystal clear. The Citroën Ami, it's a brilliant piece of engineering for one specific market. It's a masterclass in cost cutting, but its 48-volt system is a dead end. You just can't scale it up. The Wuling Mini EV, though, that car proves that our recommended 96-volt architecture is the key. It's the winning formula for balancing cost and performance in the biggest, toughest markets in the world. So this all boils down to our execution plan, which rests on 4 pillars. These are non-negotiables. 1. We standardize on 96 volts, period. We'll just use software to turn down the power for the entry-level models. 2. We design to China's no-fire battery standard from the very first sketch. 3. We use virtual simulation wherever we can to slash our European certification time and cost. And 4. Cybersecurity gets baked into the core architecture from day one, not tacked on as an afterthought. So there you have it. This blueprint gives us the flexibility and the foresight to not just enter these markets, but to actually win in this incredibly complex global game. We've created a unified solution for a fractured problem. The engineering challenge is solved. So the only question left for the business to answer is the one right here. Where do you want to conquer first?